Let's solve logarithmic equations. Now remember, we always need to isolate the log portion of the equation first. Then we want to rewrite it as an exponential and solve. So let's do it. Remember, if b to the y equals x, then the log of x base b equals y. This is how we rewrite base to the y equals x, right? That's how they're related. So when we need to rewrite our logarithmic as an exponential, that's how we do it. Okay, so let's solve. The log of 2x minus 8, base 4, equals 3. And I know when you look at this, you're like, I'm sorry, what? Okay, well, 2x minus 8, that is the entire argument. So we have already isolated the log. So we are ready to change this to an exponential. So I take the base, take it to the third power, and set that equal to the argument of 2x minus 8. All right, what is 4 to the third power? Well, 4 to the third power is 64. Okay, so 64 equals 2x minus 8. Well, let's solve it. So we want to get x by itself, so our first step is to add 8 to both sides. So I have 72 equals 2x. Last step, divide both sides by 2, and x equals 36. Now we know that our argument must be positive, so plug this back in to check. So if I plug in 2 times 36 minus 8, 2 times 36 is 72, 72 minus 8 is 64, that's positive. Yep, this works. My answer is 36. Keep your answer as a fraction for this one. We have 2 times the log of 3x base 7 equals 6. Now remember, our first step is to isolate the log. So we have 2 times a log, so we're going to want to divide both sides by 2 to isolate the log. So I have log of 3x base 7 equals 3, because 6 divided by 2 is 3. Now that I've isolated the logarithm, I can change this to an exponential. So I start with my base of 7, raise it to the third power, and that equals 3x. Well, we have to simplify. What is 7 to the third power? 7 times 7 times 7, right? 7 to the third is 7 times 7 times 7, which is 343. Now, when I take my last step and divide by 3, 3 does not go in evenly into 343. So I'm just going to leave that as a fraction. If they ask for a mixed number, it would be 114 and 1/3. But because we are dealing with thirds, this is a repeating decimal. And unless it tells you to round, you want to keep your answer as exact as possible. Let's round to the nearest hundredth. So the natural log of 2x minus 2 equals 6. Well, we have to isolate the log part. Natural logs and logs have the same rules. Just keep that in mind. So I'm going to add 2 to both sides of the equal sign. So I have the natural log of 2x equals 8. The logarithm has been isolated. So now I'm ready to change to an exponential. Well, what is the base of a natural log? Well, the base, as we know, is e. So I'm going to take e to the 8th power equals 2x, right? That's our idea of changing logarithm to an exponential. Now, when you take e to the 8th, you're going to get kind of a big number. But remember, our last step is to divide by 2. So x equals e to the 8th divided by 2. So in your calculator, you're going to want to type in e raised, put that 8 in parentheses, and then divide by 2. And you should be able to put that all in at one time, but if you're scared about it, feel free to do it as 2 separate steps. But you're going to end up with x equals 1,490, and to the nearest hundredth, 48 hundredths. That's a pretty large number. And I put that back into my log. 2 times that number is positive, and so that is fine. I believe this is the last one. Solve 3 log of 2x plus 7 base 5 equals 6. Okay, so again, we've got to divide by 3 to get the log isolated. So I have the log of 2x plus 7 base 5 equals 2. Change the logarithm to an exponential. I start with my base, raise it to the second power, equals the argument of 2x plus 7. Simplify. 5 squared is 25. So 25 equals 2x plus 7. My next step is to subtract 7 from both sides. So 2x equals 18, divide by 2, and x equals 9. When I plug that back in, 2 times 9 plus 7 is 18 plus 7, which is 25. It's positive. That works, and I know I'm correct.